we're going to start off by discussing combining like terms. And to start this discussion, you have to have a full understanding of what like terms are. So terms are a combination of numbers and variables. A term, for instance, could be a constant like 2, or a combination of a coefficient 2 and a variable x. These are two different terms, 2 and 2x. And the 2 in this case, the 2 in the first case is considered a constant and has no variable with it. The 2 in the second case is considered a coefficient because it's tied with the variable. So when we talk about like terms, we know two things have to be consistently true. They have to have the same variable and that variable has to have the same exponent. Okay? So same variable and same exponent is what gives us a like term. So for example, 2x and x would be considered like terms, and we can combine them to make 3x, right? 2x, and we didn't write a coefficient in front of the x, but we know because there is no coefficient, it's 1. So 2x and x is 3x. Or 4y squared plus 2y squared gives us 6y squared. Okay, that's another combination of like terms. And they're like terms again because y squared, x, remember same variable, same exponent. It doesn't have to be one variable. It can be more than one variable. 3xy squared minus 2y squared x equals xy squared. Notice here I've changed the order, right? I have the x and then the y squared. Here I have the y squared and then the x. That doesn't matter. It's only same variable, same exponent. Nothing about them being in the same order necessarily. So that still is considered like terms that we can combine. So here we have a expression, algebraic expression, 3x plus 4y squared minus 2x squared plus y squared minus x. Okay, and I'm going to go ahead and highlight which ones are like and which ones are not. So 4y squared is like with y squared, and negative 2x squared is not like with anything, and 3x is like with negative x. So the ones I've highlighted in the same color can be combined. Let's start with 3x and negative x, giving us, oops, still on highlighter, giving us 2x. And now we can do 4y squared and y squared, giving us 5y squared. And then the negative 2x squared isn't like anything, so we can't combine it. So we just leave it as negative 2x squared. Okay, solving multi-step equations. I'm going to be combining a couple of different elements here and working on a multi-step equation. So let's say we have 3x over 4 minus 8 times 2x minus 1 equals 36. Okay, we have a lot sort of to unpack here. And order of operations would typically dictate that we have to do what's inside the parentheses first, but there isn't anything to do inside the parentheses because, as we've just discussed, these two things aren't like terms, so we can't combine them. What we can deal with is what's going on right outside the parentheses. So this minus 8 times is like its own term. And we're going to use distributive property, which remember means that we multiply what's outside the parentheses by everything inside the parentheses to deal with this minus 8. And we have to take its sign along with it when we do this multiplication. So that's going to leave us with 3x over 4 minus 16x, that's negative 8 times 2x, plus 8, that's negative 8 times negative 1, equals 36. Now we've done away with our parentheses. Now we have to somehow combine this 3x over 4 and this 16x because they are like terms. And the best way I think to deal with this is to multiply the whole equation, every part of it, by 4. Okay? And that way, and we can really illustrate that we're doing it to both sides of the equation, so by multiplication property of equality, we're allowed to do that. In that way, we can get rid of these denominators. So if we think about distributive property again, we're going to distribute this 4 to every part of the equation, leaving us 4 times 3x over 4 just leaves us with 3x, minus 4 times 16 is 64. Mental math. 64x, and 4 times 8 is 32. Equals, and then 36 times 4, 144. Now we can combine our like terms, and we end up with negative 61x plus 32 equals 144. We can subtract 32 from both sides, and we get negative 61x equals 112. And then we can divide both sides by negative 61, divide by negative 61. And there's no simplification available beyond that. So our final answer, x equals negative 112 over 61, and we leave that as our final answer. So 2 things I want you to take away from working through this problem. Number 1, and I'll highlight them here for you, distributive property, okay? Make sure you take away how we did distributive property and how you're expected to do distributive property. And number 2, how we dealt with this fraction here, okay? Remember that we multiplied everything in the equation by this denominator here. So that's what we're going to do. We're going to multiply everything by the denominator, or the least common multiple of the denominators, to get rid of all the denominators and end up with this nice linear equation with no denominators that we can solve. And it's always fine to leave your answer as an improper fraction. That's the preferred way.